Well, hi again, this is Bob, and I'm over on page 383. We're getting ready to look at 7-2, which is remarkably close to the ideas that we saw in 7-1 when we were talking about confidence intervals. So I'm expecting, with just a few adjustments, that this lesson should be pretty straightforward for everybody. And I'm going to read just a little bit on the top of 383, but as always, I encourage you, if you haven't done so already, to do a close reading. And this recalls some of the things we did in 7-1. It says when the population standard deviation is known and the sample size is 30 or more, or the population is normally distributed, which I made reference to in 7-1, if the sample size is less than 30, the confidence interval for the mean can be found by using our z-tables, okay? Then they tell us that most of the time the value of the standard deviation isn't known, so what must be estimated, and you recall that we had the population standard deviation and then we had the sample standard deviation. And we know how to calculate both of those from chapter 3. Okay, and then they tell us that when S is used, especially when the sample size is small, critical values, when the sample size is small, critical values greater than the values for the z-tables are used in the confidence interval, and these particular critical values that are greater than the values in the z-tables come from something called the t-tables. So the t-tables are a special set of tables that we use under certain conditions. I'll be saying much more on this toward the end of this lesson, but one of the conditions is they just told us that we don't know what the population standard deviation is. Okay, and so we'll have to use our or our sample standard deviation. Okay, and this is all summarized, although we haven't seen anything yet. That's what I was trying to emphasize when I was reading on the top of page 383. Now, I'll allow you to take a look at the characteristics of the t-distribution because they're very similar to the z-distribution, but the normally, and again, I'm just kind of generalizing here, but normally we'll use these tables when our sample size is less than 30 and we don't have the our sigma, the population standard deviation. That's under the normal circumstances, okay? But again, there's other situations and we'll discuss. But the t-tables are based on a set of curves that are derived from what's called the degree of freedom, and I'm just going to try to do a little sketch here, and it's based off the bottom of page 383, and then I'll just go to the formula. But it starts out when we have a low number of a low n, that the t-tables might look something like this, but as n gets bigger, the t-tables take on the shape and appearance of our bell curve or our standard normal distribution or just normal distribution. So that's what they're trying to tell us at the bottom of page 383. So let me just go ahead and write the formula because I have a tendency to get bogged down in theory. There's only one other thing that actually the use of the t-tables and the equation or formula, as I mentioned, is very similar to the use of our confidence interval. In fact, I'm going to write the two side by side. Or one under the other. Okay, this was what we did in 7-1, and our new formula, based on our new tables, still has a sample mean, but now instead of z alpha over 2, it has T sub alpha over 2. This is at the bottom of page 384, by the way. And instead of our sigma, our standard deviation for the population, divided by root n, we're using S, which is our sample standard deviation. So what's really different here? Well, there's two things that are different, and one of them, of course, is T sub alpha over 2 versus Z sub alpha over 2. And then we have our S versus our sigma, or population standard deviation. Okay, so those are the only two things. And I want to make a comment here. I'm going to go back and review again, and as I work through the sample problems, I'll remind everybody of when we use the T-tables versus the Z-tables for confidence intervals. Okay, and there's even a little flow chart at the end of this chapter here. But I think the most important thing is to get used to the formula and the tables, and then we can come back and say, oh, this is when we would use this and why. And of course, on the quiz and on the test, when we get around to the chapter, the test on the material in Chapter 7, I will highlight the fact that we have a small sample size, or I'll give you, in some cases, a hint on our third and fourth test when you should be thinking about using the T-tables versus the Z-tables. And then one little final thing here, as the sample size for the, as the sample size increases, our Z-tables start looking a lot, or our T-tables start taking on or getting closer to the values of the Z-tables. Okay, I know that sounds wordy, but the other thing to remember is we normally use the T-tables when we don't have the population standard deviation and we have a sample size that's less than 30. Anyway, let's concentrate. We've got two more things to look at, and they tell us in the reading on page 383 that the T-tables are generated, the curves are generated by something called the degrees of freedom. And they talk a little bit about degrees of freedom and use a very simple math idea to show that. But here's the only thing we need to know. For us to use our tables, we need to find the degrees of freedom. In other words, for us to use the T-tables, we need degrees of freedom. And degrees of freedom is just equal to n minus 1. So it's not difficult to find the degrees of freedom in our table. Remember, in our Z-tables, we had they're constructed a little different than our T-tables. If you notice on the top of page 384, instead of having, well, I'm just going to tell you what they do have. They have a degree of freedom, and that runs down the horizontal column. And then they have our old pals, the confidence intervals, running across the horizontally. In other words, we might have like a 90% confidence level and a 95% confidence level and a 99% confidence level. And then there's another feature of that. If you notice where we have the degrees of freedom, they have that broken down into one tail, which we don't have to worry about in this chapter, or two tails. Just lost my pen there. And the only thing we're dealing with in this chapter, of course, in this section, is two tails. Remember, we have T sub alpha over 2. So this is the same idea in theory as we went over in 7.1. Okay? In other words, we're taking, I'll just use this, this may or may not be a perfect representation of the degrees of freedom for a t-curve there. But when we say t alpha over 2, we're talking about, again, the area in each of the tails there. And it turns out that we can find those values by using the tables, and they tell us that these tables are in the back of our book, Table F. There also, some of you may have gotten a plasticized pullout of the tables, and they're on that also. Anyway, let's do a T alpha over 2 question. This is example 7.5. I don't know why I keep losing my pen here. Okay, example 7.5, find the T alpha over 2, and they tell us it's for the 95th confidence interval. In other words, we want to be 95% certain when we set up our confidence interval, and the sample size is 22. Well, if the sample size is 22, then our degrees of freedom equal 22 minus 1, or degrees of freedom equal 21. So now we would go into the tables, we would find the 95th confidence interval, and notice that it says 1 tail and 2 tails, but that doesn't matter for us. We're just going straight down to where the degrees of freedom equal 21, and we'll come over and down, and that value there is 2.080. Well, if you remember anything from 7.1, you may recall, you don't really have to memorize stuff here because you could just go back and check it out, and I tried to emphasize the fact that we use 3 confidence intervals most often, the 90th, the 95th, and the 99th. But when we were dealing with the z-tables, our z sub alpha over 2 for the 95th confidence interval, I'll write it this way, was 1.96. Well, notice that 2.080 is slightly bigger than 1.96, and when used in the formula, it's going to make our, it's going to stretch out or increase our confidence interval. Okay, well then there's some other things that they tell us, and I think you'll see most of this when you get back and do the homework questions. But there is something that they tell us when they do, right below that table there on example 7.5, and they tell us that when degrees of freedom are greater than 30, it may fall between 2 table values. In other words, if we had degrees of freedom of 68, okay, there's a degree of freedom in our tables for 65, and there's a degree of freedom for 70. Okay, and recall, as the degrees of freedom get greater, our values approach the z-table values. Okay, so what they tell us here, and you'll see this when we get to the homework question, and of course you can check it out in the back of our book and our very valuable student solution manual. But it tells us that Minitext used the closest value, and Minitext would say, well, 68 degrees of freedom is really closer to 70, so I'll use the value for 70, and that value would be a little smaller. So our book tells us to go back and go to the smaller one, or the one before, and in that case you would go back and use the degrees of freedom for 65. Okay? Anyway, I think we're ready now to just go do a question. And again, here's a couple of assumptions when we're looking at using the t-tables. And this is on the top of page 385. We're going to find a confidence interval when a mean, or confidence interval for a mean when standard deviation is unknown. Here are the 2 assumptions. The sample is a random sample, and either n is greater than or equal to 30, or they tell us the population is normally distributed when n is less than 30. Okay, so they'll remind us of this as we go through the problems. And again, if you understood how to set up a confidence interval in 7.1. The only difference in 7.2 is that we're using T-tables instead of Z-tables. So here's the first one here. It's temperatures on Thanksgiving Day. And notice how small the sample was. A random sample of high temperatures for 12 recent Thanksgiving days had an average temp of 42 degrees. So our sample is just 12, and our sample mean is 42 degrees. That's Fahrenheit, I'm sure, yeah. Okay, and then they tell us, okay, so here's the key. They tell us the variable, even though we've only got a sample size of 12, they tell us that the variable is normally distributed and the standard deviation of the sample temperatures was 8 degrees. Now, remember, this isn't our population standard deviation. This is our sample standard deviation. Okay. Again, I'm going to stress that the standard deviation of the sample temperature was 8 degrees. If we had had the standard deviation of the what's the word I'm looking for here? I've kind of lost my train of thought. If we had the population standard deviation, then we would most likely use the Z-tables for this question. But recall, we have a small sample size and we do not have the population standard deviation. Okay, anyway, the idea is for us to solve this question, and right away I think you can see that our degrees of freedom would be 11. And I'll write these again. We have a sample mean of 42 degrees, and we have a sample standard deviation of 8 degrees. So we're ready to solve this. The only thing is the only thing that's missing is our T alpha over 2 value. And so we would go to where, and our confidence level, of course, is 95. I want to be 95% confident in our interval. And the T sub alpha over 2 that's represented that by going to 11 degrees of freedom and coming down to where it meets or going, I'll do it this way, of our degrees of freedom to 11 and our 95th confidence interval back in table F, and they tell us that that value is 2.201. Okay, so we've got everything we need to set up our confidence interval here. We believe that the true mean temperatures on Thanksgiving Day will lie between our sample mean of 42 plus T sub alpha over 2, which recall we found was 2.201, times our sample standard deviation divided by the root of our sample size. Now, remember, we use the degrees of freedom to get into the table, but we don't use the degrees of freedom in the formula. Remember that the formula calls for N, which is the sample size. Okay, then we have the same thing on the other side. And like I tried to stress in 7.1, make sure, don't just set these up and move on, assuming that you know how you could consistently work this out on the calculator. Actually take a second and work through this. Get used to your calculator and the way values are input, and make sure your answer agrees with the book. So they end up with a correction of 5.08, and they add and subtract that to 42, and they come up with 47.08 on the high side, and they end up with 36.92 on the low side. Okay, so based on that, these are temperatures, of course. Based on that small sample then, we can be 95% confident that the population mean for the temperatures on Thanksgiving Day is between 36.92 degrees Fahrenheit and 47.08 degrees Fahrenheit. Okay, well, let's do one more of these and then try to summarize again the usage of it, of the T-tables, when and why. And why don't we just finish off on the book's next example, which is example 7.7. And it's on home fires started by candles. Now, we've got a really small sample set size here. 1, 2, 3, 4, 5. Only 7, so we've only got 7 pieces of data, or 7 sample size of 7. And I'm going to take the word that this represents, the data represents, that's kind of surprising, that many fires started by candles for the past several years. Find a 99% confidence interval for the mean number of home fires started by candles each year. Now, notice this is only a 7-year sample, so there are other years out there, obviously. So we're going to be dealing with a sample mean and a sample standard deviation. And I'll keep in mind that we want the 99% confidence here. And I'm going to take the book's word that the sample mean is 7041.4. That's the mean number of fires per year. And that our sample standard deviation is 1610.3. Those are easily found, although the standard deviation for that sample is a much more involved calculation, you may recall from Chapter 3. We know that if our sample size is 7, that our degree of freedom is 6. Remember that degrees of freedom equal n minus 1. So what we would do first to find we have our degrees of freedom, we would go down on table F to 6, and then would read across to the 99%, where we want to be 99% confident. And that value, according to the book, is 3.707. Well, we're ready to go here. It's just a matter of plugging this data in. And again, remember, it's a very small sample size, certainly less than 30. And recall also that we do not have the population standard deviation. We have the sample standard deviation. So this would be our setup here. Sample mean of 7041.4. Plus our 3.707 times the standard deviation, and that's the sample standard deviation of 1610.3, divided by the root of the sample size, not the degrees of freedom. I hope you're noticing that these really stretch out our intervals. When you're using the z-tables, those values are correspondingly much smaller, so they only add and subtract a little bit from the sample mean. But when we're using the t-tables, they increase the sample mean, the number that's subsequently added and subtracted, by quite a bit in comparison. I just 7041.4. Sometimes my pen takes on a mind of its own. Minus, I'm going to have to write this off to the side here. Well, you can follow in the book there, but to be 99, using the 99% confidence interval, we would end up at 9297.6. 9297.6 number of fires on the high side and 4785.2 on the low side. And summarizing, we can be 99% confident that the population mean of the number of home fires started by candles each year is between 4,785.2 and 9,297.6, based on a sample of home fires occurring over a 7-year period. Personally, I find that a little scary that that candles can cause so many fires. So, but I know that we have set up and followed their instructions, and I verified their numbers earlier, so that's fine. All right, let's close off on this by looking at the top of page 386. It tells, there's a little flow chart there, but basically they tell us below the flow chart that sometimes we have, class members have a difficulty knowing whether to use the standard normal distribution tables or the t-tables when finding confidence intervals for the mean. And so here they summarize everything. If we know the standard deviation, the z-tables or z alpha over 2 values will be used no matter what the sample size is, as long as the variable is normally distributed or greater than or equal to 30. Now that's stuff that we learned in the previous section there. And when standard deviation is unknown and n is greater than or equal than 30, S can be used in the formula and the t-tables can be used. Finally, when the standard deviation is unknown and n is less than 30, S is used in the formula for the t sub alpha over 2 values, and they're used as long as the variable is approximately normally distributed. Okay, so here's the idea, and this is another thing I like about this book. Everything in 7.1, all the situations dealt with z-tables, and they emphasize the fact about the standard deviation being unknown. All the questions you're going to run into, or the majority of questions you'll run into after we learn to use the tables on section 7.2, have to deal with using the t-tables and the rules for using the t-tables. So you'll read carefully each question. Like if you recall, when we did the first example, they told us that this was 7.6. Assume the variable is, we had a very small sample size, just 12, but they told us to assume the variable is normally distributed, and they gave us the sample standard deviation. That's why we used the t-tables with that very small sample size. We didn't have the normal of the population standard deviation. Okay, well, I'll be back shortly with section 7.3, which is a lot like 7.1 and 7.2. So I'll be back shortly. Thank you.